Welcome to week 6. In this week, we're going to start a new topic, which is logic, and this topic will continue for several weeks to come. In this lesson, we'll briefly review what Boolean logic is, and we'll look at the Boolean concepts of equivalent and negation, and briefly think about how these ideas might be used in real life. The concept of logic has been around for thousands of years, but modern Boolean logic was named after a mathematician called George Boole, who invented the symbols that we use. Computer processors are built from circuits which can let electricity through or block the electricity, and the action of these circuits matches the operators in Boolean logic. In this lesson, we'll look at the simplest of these circuits, the NOT gate. We've talked a lot about expressions. Well, if two expressions are logically equivalent, it means they have the same logical value. We could say that A means the same as B, or that A has the same truth value as B. Or if we know what A is, then we automatically know what B is. And in electronic terms, it would mean a circuit that just transmits electricity without changing it at all. And using logical symbols, we'd write it like this. Sometimes we just write A equals B, or we use a triple line like this, and that means A and B are logically equivalent, similar to saying that two expressions are mathematically equivalent. And we can represent the action of this circuit by using a truth table, and the truth table shows the inputs to the circuit and the output from the circuit. So if the input is off or false, the output will also be off or false, and if the input is on, the output will be on. We can also simplify that down to noughts and ones. Naught represents false and 1 represents true. Or we could say naught means a circuit is off, there's no electricity, and 1 means there is electricity. The next simplest operation is negation. And negation is similar to the way the word not works in everyday speech. It reverses the meaning of what you're saying. And a not circuit works in the same way. It swaps the electrical charge. So it turns an on to an off, or an off to an on. Here's the Boolean expression for A is equivalent to not B. So that symbol there, that stands for not. And the truth table for a NOT gate looks like this. If the input is true, the output is false. If the input is false, the output is true. Or simplifying it to ones and noughts, that's the logic table. We call that a truth table, and it shows the inputs and outputs of a logic gate. And if we want to draw the gate, so we're actually drawing a picture or diagram of the circuit, every time there's a NOT gate, we draw it using this symbol. It's got one input and one output. We conventionally label the inputs and outputs with letters of the alphabet, and there's one wire going into the gate and one wire coming out. So if X is on, Z would be off, and so on. Signal on, signal off, or vice versa. And we can think of many examples where NOT circuits would be useful in everyday life. For example, here is a way of opening a door. You press your fingerprint against a scanner, and if it will read biometric reader. And if it detects the correct fingerprint, then the alarm will not sound. And if it does not detect a fingerprint, then the alarm will sound. So it reverses, scanning the finger reverses the alarm signal. So there's the truth table, a true biometric, false alarm. false biometric, true alarm. A lot of this work is easier to do by just writing it with a pen in your notebook, but if you do want to type this into Word, if you go to the Input tab and look for symbol and press the down arrow below symbol, you'll see a table of characters, and all the logic symbols you need are in that table of characters. So let's just summarize what we've learned about NOT. The NOT gate looks like this. It's a triangle with a little circle. The circle is important. If you leave that out, it won't be a NOT gate. It won't be the correct symbol of a NOT gate. The truth table looks like this, and the Boolean operator looks like this. So you need to learn all of those things. So in this lesson, we've just introduced the idea of Boolean logic. We've looked at equivalence and negation and the circuits that work with those and how they might be used in real life. So as an exercise, you need to put this into your revision book. So get your revision book, right at the top, Q is equal to not A, and then represent how you would write that as a gate, as a truth table, and as a Boolean algebra symbol. Okay, so 2, 3 more operators in the next lesson. Bye for now.